All right, today we're going to talk about a massive shift in how we defend our digital lives. It's called cognitive security. And look, this isn't just about building higher walls or bigger moats. It's about designing defenses that can actually think, learn, and adapt on the fly. So let's get right into it. This really cuts to the core of the problem, doesn't it? For so long, cybersecurity has been a waiting game, a reactive game. We've basically been stuck in a defensive crouch, right? We wait for an attack, then we patch the hole. We wait for a breach, then we clean up the mess. We're always playing catch-up, and the bad guys just keep getting faster and smarter. So it makes you wonder, right? What if our defenses weren't just static, dumb fortresses? What if they could actually learn from every single thing thrown at them? What if they could anticipate the next move and evolve right there, in the moment?
Well, the answer is a complete change in mindset. We have to stop thinking about a simple digital wall and start thinking about creating a digital brain, a defense that genuinely thinks for itself.
Okay, so what is cognitive security, really? Think of it like this. It's cybersecurity, but supercharged with machine intelligence. It's all about building systems that learn the same way we do, by spotting patterns, understanding the context of a situation, and actually learning from experience. And this is the real game changer. You know, a normal firewall might just block a bad IP address. End of story. But a cognitive system, it wants to know why that IP is a threat. What is it trying to do? And more importantly, what's its next move going to be? It's the difference between just seeing a threat and truly understanding it. So let's just lay it out side by side. The old way, traditional security, is all about known signatures and static rules. It responds after you've already been hit. But the cognitive way, it's based on behavior. It learns, it adapts, and the whole point is to predict and stop a breach before it can even happen.
Okay, I know what you're probably thinking. This sounds great, but how does the system, learn? Well, the secret sauce is something called the feedback loop. You can think of it as the engine that drives all of this adaptation.
It's a really simple but incredibly powerful cycle. So first, the system spots an anomaly. Something just isn't right. Next, the AI jumps in and analyzes that event, comparing it against millions, maybe billions of other data points. Then, based on what it finds, it updates its own defense model. And boom, the whole system evolves. It just got smarter.
And that brings us to this really powerful concept. A failed attack actually makes the system stronger. Think about it. When a brand new phishing email gets blocked, the system doesn't just toss it in the trash. No way. It tears it apart. It analyzes the language, the way the links are structured, where it came from, and then it shares that knowledge with the entire network. So the next time an email like that shows up, it's caught instantly. Every single attack becomes a lesson. Now, let's talk about the elephant in the room, right? A lot of people hear AI and immediately think it's here to replace human experts, but with this, the reality is the complete opposite. This is all about partnership. It's about magnifying what humans do best with the raw power of AI. Just think about the scale for a second. Millions. We're talking millions of data points. Every network packet, every user login, every system log being analyzed every single second. That's a level of vigilance it's superhuman. There's no way any team of people could ever keep up with that. And that's precisely why this is a partnership. The AI does the heavy lifting. It wades through that ocean of data and flags the things that actually matter. That frees up the human analysts to do what they're brilliant at. Strategic thinking, using their intuition, applying their deep expertise. It's a total force multiplier.
And this partnership, it unlocks something incredible. Real, data-driven prediction. We're moving beyond just guesswork. This is about probabilities. Let me show you how it works.
Okay, so picture this. The system flags a login at 3 a.m. By itself, that's maybe a little weird, but not a huge deal. But the AI instantly connects that to another piece of data. This login is coming from a device that has never been on the network before. And then a third piece clicks into place. It's from a city thousands of miles away. See? On their own, they're just little oddities. But together, they're a pattern. And because the AI connects these dots in milliseconds, it doesn't just sit and wait for data to be stolen. No, it predicts a high chance of an account takeover, and it acts immediately. It might force a multi-factor authentication check or just lock the account down. And just like that, the attack is predicted and prevented. A lot of the time, before a human analyst even gets an alert.
So you see, it all comes back to that amazing partnership. It's a two-way street. Humans train the machine, give it context, and keep an eye on it. And in return, the machine gives us insights and automation that make our human defenders stronger and more effective than they've ever been.
But of course, with this kind of power comes huge responsibility. We're not just building tools here, we're essentially building the guardians of our digital future. And that means we have to think really, really carefully about what it means to have an intelligent, autonomous defense system.
And that brings us to the central challenge, the big question we have to wrestle with. An AI that can decide to lock someone out of a critical system, that's real power. So how do we build these intelligent defenders without, creating opaque, unaccountable judges?
Yeah, these are the tough ethical questions we have to build answers for. What happens if the system gets it wrong and locks a doctor out of a hospital network during an emergency? How much visibility do we get into its decisions? And who's responsible when it makes a mistake? These aren't just questions for engineers. They're questions for all of us.
And here's the bottom line. In the very near future, our whole world is going to depend on systems like this. I'm talking about our hospitals, our power grids, our financial systems, all of it. Our safety, our stability, it all hinges on our ability to build defenses that don't just react, but can actually think.
So I'll leave you with this one last thought. The strongest system isn't the one with the highest walls, the one that never falls. It's the one that learns how to get back up and stand stronger every single time.